Friends, welcome to our channel. Let's have a look at problem 408, valid word abbreviation. This problem is marked easy by LeetCode. However, this is actually really interesting question, which I regard it as medium. So here we are going to use two-pointer sliding window to address this problem. So here it's important to digest the rules uh, in the abbreviation. So, however, I'm not going to read through the problem statement, right? So you can try to digest by yourself. So now let's focus on the main idea and the code. So here, the method is going to be two-pointer sliding window method, right? So there are several caveats as I listed here, 1, 2, 3, right? All those are not matching. So for the coding, first I'm going to translate this one into a list. So for example, we have I, we have 12, right? Then we have I, we have Z, then we have 4, we have N. So we want to discretize. So for this purpose, I'm going to write a function first. So this is to, just make it more modularized. So we can write a function called pass. So we're going to pass the given abbreviation, right? So in this pass, so we're going to encode all the main logics. So here I'm going to initialize a stack. So for this, let me just for this, let me do a for loop. So for character in abbreviation, right? So if the character is digit, if this is the case, so then we consider two cases. If the previous one is also a digit, so then we need to multiply by 10 and then add the current digit, right? So now let's check if stack and is instance. So the first one, that is a stack top, right? Stack -1 and int. So if this is the case, so the previous number, it should be stack pop, right? Then the stack should append 10 times the previous, then plus the current digit. So obviously it's integer of character, right? So this is the one case. Another case is that if the stack is empty or the last one is not a digit, then we want to check if integer character is 0. So in other words, you have superfluous zeros. This should return false because not to match. So we are going to directly return for the result, right? So we are going to return false for the whole problem when we call this pass, right? So otherwise, so what do we do? So we are going to stack append integer character. So this case corresponding to the start. For example, this one, when you put 1 into the stack. But if you put 2, so you are going to have 1 times 10 plus 2, right? So that's the logic. So now this is a case when we have a digit string. So otherwise, so if it's a character, so we just need to append the corresponding character. So then we just return the stack, right? So notice that it might be good. So if we do not write this stack, but directly write this function, but let me first comment this this format. So now let's see what should we do. So we can call the stack equals plus the abbreviation, right? So if not stack, in other words, in between we returned false, right? Or just nothing. So we are going to return false, right? So I feel that might be not the best choice, but this will be still good. So next, we are going to do two-pointer sliding window. Two-pointer sliding window. So for this, we need so the sum of jumps will be the numbers in the stack. So let's see. So we will have n m equals the length of the word and length of the stack. So typically the length of the stack would be less than or equal to n because this is the original one. So this is the operations corresponding splits, right? So we point ij to be 0, 0 at the very beginning. So while I less than n and j less than n, then if its instance stack j is an integer, right? Then the I is incremented by stack j, and the j is incremented by 1. That's the one. Otherwise, so what do we do? If stack j does not equal to word I, so in this case, we return false, right? Otherwise, if they were equal, so we do j increment by 1, I increment the also by 1, right? So the sliding window result will be the following. We should have I equals n and j equals m. So this way of writing is to avoid this caveat, length mismatch, right? So let me first run it. So memory is not defined. Do you mean, so here, let's say a previous. Yeah, it passes the two test cases. Now let's look at the generic case. Index out of range. Let me see which part. It's in line 38. So if instance stack G integer. So here, yeah, I guess f this one is m, so G is less than m. Yeah, it passes all the cases and very fast. So this is the one way, but here I put these things into a into a function. So, but if you do not want to do this, so you can actually do this. So let's call this one version v1. And what we do here is that we can delete this part and then also delete this part. Then we can sync one tab here, right? So we do the parsing first, and then in between, so we have some returns, right? And then I don't need to do this, right? Do this call. And then if not stack, we also return false, then the remaining will be the same. So as I have changed this one to be version v1, so now if I check, I'm checking the second one. And passes all the things. So this is the one. Actually, you can also using modify this function if you write in this format, to write in a slightly different format, but the logic will be the same. So with that said, I guess that's the full coding for this problem. So here actually there are two parts. One is passing this operation as as digits, as numeric numbers, string, and also the characters. And then we match the scenes by 2-point sliding window. So that's about it for the current video. Thank you for watching.